welcome to you all for today's PV Tech webinar in association with Jolywood. My name is Ben Willis. I'm the Managing Editor of PV Tech. Today we're going to explore in detail the Jolywood Windproof PV Module, a product that's been designed to operate in some of the world's harshest environments. It's no small irony that the same extreme weather conditions solar is being deployed to help mitigate are also becoming an issue of growing concern to those involved in the business of building and operating PV power plants. One of the predicted and now increasingly evident consequences of man-made climate change is the growing prevalence of extreme weather conditions, heavy winds and destructive hailstorms, to name but two. These increasingly erratic weather patterns are sounding the alarm bell for PV power plant owners. A growing number of them are experiencing force majeure damage to their hardware from hail, high winds and other unpredictable weather events. Hail has gained particular notoriety in the past few years for causing significant damage to PV systems and has become a leading source of insurance claims within the industry. The result of this is that for manufacturers of PV hardware, the reliability and durability of their products in extreme conditions are coming under increasing scrutiny, necessitating new engineering solutions to ensure continued operation in even the most rigorous conditions. Jolywood's Windproof Module is a prime example of the innovative solutions being deployed in response to the durability question. The Windproof Module is engineered to withstand the rigors of complex and varied environments and climates, ensuring its high efficiency power generation capability is maintained throughout its entire life cycle. Additionally, the Windproof Module's lighter weight compared to traditional double glass modules also offers another advantage by broadening the range of installation scenarios. I'm pleased to welcome today Anne Chow, Product Marketing Director at Jolywood, who's our guest speaker today. Anne, in a moment, will walk us through some of the key features of the Windproof Module and its ability to handle issues such as damp heat, UVID and PID. As is the usual format with our webinars, after the presentation, we'll open the floor to all of our viewers today for questions. This interactive element is a great opportunity for you to gain further insights into our topic today. So please submit any questions you may have for Anne in the questions tab at the bottom right of your screen, and we will do our best to get to them. Early on in the webinar, there will also be a poll for all of you viewing today to respond to, so keep an eye out for that. At the right moment, it should pop up somewhere on the bottom of your screen to fill in, so keep an eye out. But that's enough from me for now. I'd now like to hand over to Anne for today's presentation. Anne, the floor is yours.
Okay, thank you, Ben. Hello, everyone. Thank you for joining today. I'm Anne Chow from Jolywood. It's my pleasure to introduce Jolywood Windproof Module, which has been specifically designed to meet the increasing challenges posed by climate change. Today, we will explore how this innovation not only withstands extreme weather conditions, but also enhances performance and sustainability in solar energy generation. Firstly, let me introduce our company Jolywood through this picture of our innovative windproof module. This module highlights our comprehensive in-house manufacturing capabilities, including PV module, solar cells, backsheets, and encapsulant. Jolywood leads the global market in photovoltaic materials, particularly known for our backsheet, where we maintain the top position in market share. This expertise extends to supporting over 260 gigawatts of power plants worldwide, underlying our significant impact on the industry. Our Jolywood solar cell delivers a superior performance with our TOPCon solar cells, achieving a remarkable lab efficiency of 26.7%. These cells are produced at our advanced 20 gigawatt facility in Taiyuan, Shanxi. The PV module have reached the global shipment of over 11 gigawatts from our facility in Taizhou, Jiangsu. And beyond manufacturing, our Jolywood Solar System division has grown to become one of the top 5 residential system brands in China, managing and operating over 190,000 household PV systems. Before diving into the technical details, I'd like to frame our discussion with this key point just from a recent TED Talk on climate change. As the slide shows, the global carbon budget that remains to keep warming below 1.5 degrees Celsius is rapidly depleting. At current emission levels, we are excited to use up this budget in just 5 years. This urgency highlights the critical role of renewable energy, particularly solar power, in reducing emissions and securing a sustainable future. Reducing carbon emissions is critical to limiting global warming to 1.5 degrees Celsius. However, climate change is increasing the frequency and the severity of extreme weather events, posing significant challenges to renewable energy systems, including PV modules. One such challenge is a significant rise in hails, as seen in the data on this slide. Since 2021, the number and the intensity of hail events, especially in Europe, have surged. Large hails are now more common, becoming a major cause of damage to PV systems. Hail has also emerged as one of the leading factors contributing to insurance claims. For PV technology to continue playing a vital role in the global energy transition, it must be resilient. That means developing modules that can withstand these increasingly harsh weather conditions while still delivering reliable, clean energy. With advanced engineering, we can mitigate these risks and ensure PV systems remain a key part of our sustainable future. Okay, now I'd like to engage everyone with a quick survey, considering our discussion, which characteristics are most important to your PV module. Please click the poll on the bottom menu and do your selection. Please just select only 2 options, which are the most important in your opinions. Okay, I will give more 10 seconds and let's see the results. Okay, now we got 23 votes, and we can say the high reliability and durability received the most selections. That's the answer actually I was hoping for. Thank you. Now let's move on to the development of PV modules, focusing on two key pillars, efficiency and reliability. On the efficiency side, we are continually enhancing cell technologies, optimizing encapsulation materials, and increasing wafer and module size to maximize energy output. For reliability, we are engineering PV modules to withstand the environmental impacts, including wind, snow, hail, UV exposure, and extreme temperatures. This focus on durability ensures that PV modules deliver long-term performance. Given the accelerating pace of climate change, I would like to say reliability and durability are more critical for PV modules. That's also the background behind why Jolywood developed the windproof module. Let's take a closer look at the windproof module. This presentation will highlight three crucial components that Jolywood manufacture has innovative design. The TOPCon cells, a transparent mesh backsheet, and the backbone steel frame. At this stage, we will focus on these components, understanding their design and integration into the module. Let's dive deeper into the TOPCon cells, which are one of the most critical components of our windproof PV module. Two key technologies are driving its performance. Firstly, the PVD technology. Jolywood's innovative planar PVD technology streamlines the manufacturing process by eliminating the wraparound step. This not only makes production more cost-effective, but also improves the yield rate by 3% and enhance cell efficiency by 1.5%. And then GSIM technology. Since 2021, Jolywood has developed GSIM in-house. This new metallization technique introduced an optimized metal paste system that significantly reduces contact resistance and contact recombination current. This innovation improves the module's heat and humidity resistance, further enhancing the reliability of bifacial single-glass TOPCon modules. Next, we have the transparent mesh backsheet, which plays a critical role in enhancing the performance and the durability of our PV modules. It integrates two key innovations. The Jolywood Hallberg Tech. Jolywood Hallberg Tech uses a self-manufactured organic-inorganic hybrid nanocomposite, offering twice the UV resistance of traditional backsheets and over 93% light transmittance. This backsheet has passed stringent testing, including 500 kilowatt-hour per square meter UV exposure and 3,000 hours of damp heat testing, ensuring long-term durability. Also, it integrates self-cleaning technology, which can improve long-term performance. Then the backsheet has the high reflective mesh coating, designed with a reflective mesh coating between the solar cells. This technology allows light to reflect a second time, increasing light intake and boosting the module's power output. This can add over 10 watts to the module's performance. Now let's move on the backbone steel frame, which is another critical component of the windproof module, designed to improve durability and efficiency. the material, the backbone steel frames, zinc, aluminum, magnesium surface alloy, and high-strength steel substrate provide durability compared to traditional materials. And the structure, the frame is built with a special double beam structure. This design enhances its strength while also optimizing the module's overall performance. The frame strength is 50% higher compared to conventional aluminum frames, ensuring better mechanical protection. It has a shorter C side, which can provide a higher beneficial rate, meaning more energy generation from backside. The A side heat is lower, which helps reduce dust accumulation and decrease the risk of hotspots. Additionally, this frame contributes to lower carbon emissions, about a 45% reduction in emissions compared to aluminum frames when just considering glass, backsheet, and frame materials in double glass modules. Here we compare the windproof module to a similarly sized double glass module. Both modules provide comparable strength, but the windproof module has a significant advantage in weight. Thanks to the constructions of single glass bifacial PV modules, it weighs less, making it ideal for installations where weight is a concern, such as rooftops. This lighter design reduces stress on rooftops while maintaining structural integrity, making it an ideal solution for buildings with load-bearing constraints. Now that we have detailed the innovative components of the windproof module, let's explore the significant benefits they bring to the overall performance and the sustainability of the module. Integrating these technologies, a windproof module not only achieves a higher energy yield, but also features enhanced efficiency with a lower temperature coefficient and operational temperatures. As we transition into the next part of our presentation, we will discuss the direct impact of these advancements on efficiency, reliability, and sustainability. Upcoming slides will provide the data and the performance metrics that showcase their value to our customers. Let's take a look at some real-world performance data. We conducted a year-long side-by-side comparison at one third-party test base, CPVT demonstration base in Yingchuan, Ningxia, comparing the windproof module with a double glass module. The results showed that the windproof module generates 1.63% more energy than the double glass module. This performance gain is attributed to the advanced technologies we incorporated, which optimize energy absorption and reduce operating temperature. As we delve into the high reliability of our windproof module, we start by addressing a significant industry challenge: dampage resistance in TOPCon solar cells and modules. Today, we will explore how Jolywood's innovative approaches tackle these issues. We begin with a collaborative study conducted with the University UNSW, which investigates the effects of our GSIM technology on the reliability of TOPCon solar cells. This research is crucial as it lays the foundation for our next discussion on module performance under extreme conditions. This research clearly demonstrates that our GSIM technologies enhance both the efficiency and the dampage resistance of TOPCon cells by optimizing cell metallization. GSM significantly reduced performance degradation under damp condition, which is a common challenge in solar module reliability. This improvement ensures that our cells perform reliably even in harsh environmental conditions, supporting the overall stability and output of our PV modules. For the improvement through GSM technology, let's look at how the windproof module itself stands up to rigorous damp heat tests. This is a critical factor for TOPCon modules, given their vulnerability to such conditions. Our continuous efforts in enhancing product reliability are reflected in the latest testing outcomes. After 2,000 hours of damp heat testing, our module showed a power degradation of just 3.4%. Moreover, it demonstrated only 3.05% degradation after 192 hours of PID testing. These results not only highlight the module's superior damp heat resistance, but also its reliability and long-term stability, ensuring optimal performance over its lifespan. UV resistance is another key factor when evaluating the durability of TOPCon modules. According to the brief summary of PVEL 2024 scorecard, it was found that more than 50% of the TOPCon modules tested exhibit power degradation greater than 5% after just UV60 testing. However, the windproof module has shown significantly better results after UV120 testing. The average power degradation across two sample modules was only 2.62%. And the degradation from UV60 to UV120 was only an additional 0.5%, which highlights the outstanding UV resistance of the windproof modules. In addition to these results, we will also conduct more rigorous combination UV agent testing in our own lab. After 3 times UV60 plus damp heat 400 test, the module's power degradation was just 4.48%, and after 2 times DH 200 plus UV60 plus HF10 test, the degradation was only 3.85%. These findings demonstrate the excellent long-term UV resistance of the windproof module, ensuring its stability and reliability under UV exposure. The windproof module also have good performance regarding the thermal loss, with a lower temperature coefficient of minus 0.277% per degree Celsius, which can make it have a fewer power loss during high temperature operation conditions. Additionally, the transparent mesh backsheet promotes better heat dissipation, reducing the operating temperature by 1.5 degrees Celsius compared to double glass modules, contributed by the design of the frame. A-side heat is lower, effectively reducing dust accumulation and lowering the risk of hot spots. Next, let's look at the heat resistance of the windproof module. We conducted a systematic heat test comparing the performance of the windproof module and the traditional double glass modules on the different glass thicknesses and ice ball sizes. The windproof module's ability to withstand 45mm ice balls, even with thinner glass, underscores its exceptional durability and resistance to extreme weather. On the other hand, the double glass modules failed to pass the 45mm S-balls test, highlighting a key limitation when subject to large hills. This high level of performance, backed by rigorous testing, makes the windproof module a reliable choice for installation in regions prone to harsh weather events, ensuring long-term protection and efficiency. The windproof module has been rigorously tested for resistance to high winds and storms. It passed the 16 meter per second wind tunnel test, equivalent to a Category 17 hurricane. Also, windproof module undergo rigorous testing, including static load of 6,600 Pascal on the front side and 3,200 Pascal on the back side, as well as dynamic load testing 100 Pascal on both sides for 10,000 cycles, demonstrating excellent resilience in extreme weather conditions. Moving on, while examining the windproof module's superior resistance to burst, especially when compared to double glass modules. Double glass modules with their heat-strengthened glass on both sides are prone to burst caused by various stress and impurities, such as lamination stress, mechanical stress, thermal stress. A windproof module featuring tempered glass and a transparent mesh backsheet significantly reduce internal stress and weight, thus minimizing the risk of glass burst. In terms of sustainability, the windproof module excels with its low carbon footprint. Thanks to the innovative backbone steel frame, the overall carbon emissions of the windproof module are reduced by 10.19% compared to double glass modules of the same size and specification. This reduction in carbon emissions not only aligns with industry efforts to create more environmental friendly solar solutions, but also supports global initiatives for lowering carbon footprints in the renewable energy sector. The windproof module offers a solution that combines high performance with significant environmental benefits, making it a standout choice for eco-conscious projects. The windproof module is not just a product, it is a complete solution. By combining TOPCon cells, transparent mesh backsheet, and backbone steel frame, this module is designed to fit the most common PV module specifications. This adaptability makes it suitable for a wide range of applications, from residential installation to industrial scale projects and utility scale solar farms. The windproof module provides a reliable, high-performance option for various types of solar power systems. Through the windproof module, we demonstrate our commitment to providing high-quality, integrated solar solutions that harness the same sunshine for more value, promoting a sustainable future globally. Okay, thank you for taking the time to learn about the Jolywood Windproof Module. For more information about our company and our products, feel free to follow us on WeChat, LinkedIn, and Facebook. Thank you.
Thank you very much, Anne, for that very detailed and very insightful presentation. Great stuff. Quite a few questions coming in. Quite a few actually have already been answered by your colleagues, but I'll just pick up a few themes which might be good to talk about for those viewing who haven't been following what's coming in on the questions. There's quite a bit of interest in the the transparent mesh back sheets that you are using in this module. I wonder if you could just, you did refer to it a few times in your presentation, but I wonder if you could just give us a little bit more insight into the back sheet, as it seems to be quite a key feature. Some information about its composition and its chemistry, its performance relative to a double glass construction. Just a few more details around that, I think people would appreciate, if that's okay.
Okay. As I just discussed for our backsheet, I talk about it. It's using our Jolywood Hofburg tag. Actually, for the in chemical, this material is coated with double-sided fluorine carbon resin. The inside layer is PET. So for the double-sided fluorine carbon resin, with a high bond energy of its carbofluorine bonds, that their special molecular structure. That is why this backsheet have a good performance for UV resistance.
Great, thanks very much. And again, a few questions about another sort of standout feature, I guess, which is the frame. Again, you did share some interesting detail on that. A couple of questions. One is regarding the corrosion resistance of it. Obviously, it's steel, whereas typically we see aluminium used in frame. I wonder if you could talk a bit about the corrosion resistance of the frame. Also, we had a questioner ask about clamping solutions for, I guess, interacting with this particular frame, this type of frame, and what a sort of appropriate material for clamping would be. So a couple of questions there about the frame.
Okay, that is a very good question. Actually, for this steel frame, we about the corrosion resistance, it's our major concern when we design this component and when we want to apply this component in our modules. Actually, the steel frame is coated with zinc, aluminum, magnesium alloy. This coating really help protect it from corrosion. Also, we conduct many tests, many verification tests to prove the corrosion resistance of this steel frame, like salt spray test for 4,000 hours and 3,000 damp heat test. For salt spray test, after this test, there is no red rust on the 3 millimeter scratch. We also conduct other tests to verify the corrosion resistance of this steel frame. Right now, just from the test and also from the project on site, the corrosion resistance of this steel frame, there is no problem. It's okay.
Thank you very much. Just a question about the wind load resistance aspect of it. You mentioned, I think, 60 meters per second level that the module had passed in a wind tunnel test. I mean, I guess wind tunnel is one thing, but you know, sort of real life project situations is a different story. I wonder if you could give a sense of how the module, in your experience, so
okay. Yes, I agree with you. Our windproof module has passed a wind tunnel test with a higher wind speed, and actually the real world, and when the module is installed on the field, on the site, it has some different situations. But for our windproof modules, actually just this month, there is a powerful typhoon hit Hainan province, China, with winds as strong as the maximum speed is 60 meters per second. Actually, I will say it's the maximum speed, and also which is almost the same speed we tested our windproof module. During these storms, many homes with solar panels saw damage, and some panels were even blown away. This caused not only damage to property, but also serious safety risk, making the impact of such extreme weather even worse. Actually, we just have a rooftop system. We installed our windproof module. This system was not damaged at all, which shows our steel frame modules are much stronger and can better withstand high wind and heavy loads.
Great, thanks for that extra information there. Just in terms of the some of the degradation issues that you mentioned, I mean, I think it's fairly well recognised that TOPCon modules have some issues with UVID degradation, and I think from what you shared in your presentation, it looked as though your N-type TOPCon modules were slightly better than others in some UV degradation testing recently compared to others. Can you give us a bit more of an idea about the you know, why you're able to get this sort of better performance on UVID particularly?
Okay, actually, it's not an easy question for me to answer, but I will recall if I can remember what our cell expert explained to me previously for this question. As I just talked about the backsheet, so for our backsheet, our backsheet contribute this UV performance from backsheet side. Let's move on the solar cell side. Our Jolywood G-TOPCon cells, it use a stacked passivation layer on the front surface, where the core passivation layer of aluminum oxide film is applied using ALD technology, which is plate automatic layer deposition. This process creates a passivation film that is more uniform and denser. Also, we additionally, the thickness of the passivation film we conduct further optimization and adjustment, which can reduce the defect density caused by UV light. This can enhancing the cell's UV resistance, and then combine the UV resistance capability from our backsheet. I think this is why our module have good UV resistance performance.
Great, thanks. I think we just got time for one last question about, well, let's wrap two into one. Applications in the field, whether there are any applications that this module is better suited for, for example, utility scale or rooftop, and whether there's any difference in the installation methods for the windproof module compared to standard ones. I mean, I guess it's got a couple of unique features with the frame being what it is and the back sheet, but I just wonder if you could address those two questions finally.
Okay, so as I just talked, our windproof module is just not it's not just a product, it's also a solution. So our windproof module are suitable for many scenarios, for utility scale PV station and for rooftop systems. Regarding the installation method, as you just asked, actually when we design this module, when we want to apply the steel frame, we already fully consider the adaptability of the installation method. So the steel frame has been designed to be consistent with the installation hole position and the method of current aluminum frame modules. In order, we do not want to increase additional installation cost. So our windproof module, it can be adapted to the mounting system rack, which used by conventional aluminum frame PV modules.
Great stuff. Well, I'm afraid we are out of time. So thank you very much, Anne, for your insights there. That's been really interesting. And yeah, just looking at questions that have been coming in, if there's any that haven't been answered, then, people who've asked them can, of course, follow up with Jolywood after this webinar is over. Presentations, the presentation you've heard will indeed, as some of you have asked about, be sent out after the webinar. The webinar will also be available to watch again. If there was anything that you missed first time around, that will be available through PV Tech very soon. So that is it from us today. All sponsoring today's webinar, and of course to Anne Chow for his expert guidance on the topic today. Thanks very much, Dan. From me and all the team at PV Tech, thank you all for tuning in, and have a very good rest of your day. Thank you very much.
Thank you.